All right, so let me introduce our speaker. Dave McGill is the Extension Forestry Specialist in West Virginia. He's with the West Virginia University Extension Service and their Appalachian Hardwood Center. I've known Dave for many, many years. We get together at least once a year when all the extension foresters in the Northeast meet. It's always a lot of fun, and I've had great interactions with Dave, and he's done some really exciting programming things in West Virginia. So he's offered to give this presentation on an introduction to silviculture, and I agreed. And so I want to thank Dave for preparing this. I saw a preview of it, and I'm excited to see it, and I know it's going to be a great webinar. So with that, I'm going to mute my microphone. Dave, the floor is yours, and thanks for joining us.
Well, thanks a lot, Pete. It's exciting to be here. I know you've done this for many years, and I look at it as the Cadillac of webinar series, so I'm very happy to be here. So a little bit about my background is I came to West Virginia via a circuitous route. From California, I studied forestry, went to the Peace Corps, did the arid land forestry, wound up in Virginia where the woman I met in the Peace Corps lived, and made my way to Madison, Wisconsin and Penn State for my PhD. And then I got my first job down here with Westvaco Corporation, where I was a hardwood silviculture scientist. I was focusing on natural hardwood regeneration and how they could get better forest composition, better makeup of their forests as they did their very intensive timber harvesting. And so it's great to be here. And like Pete said, it was actually him that suggested we do another introductory silviculture talk. And he thought because it's been visited a couple times here on the web, on this webinar, that it might be just time to reintroduce it. So one of the little sayings that we hear is that if you take 20 foresters into the woods, you get 20 different management prescriptions. So hopefully this silviculture talk, this introduction to silviculture, will give you just a little something different from some of the others. I talk about silviculture to landowners in my job, both out in the woods and in the classrooms in different settings. So one of the things about silviculture is very complex. And so hopefully today we can approach some of this complexity, but in a way that kind of leaves you some context or a wider point of view about what silviculture is and how it works. I noticed that, can everyone see this little pointer, hopefully? I'm still getting used to this. Assuming that's a yes. And today, part of this, I'd like to first start by defining silviculture, getting a general sense of what it is and who does it, and then talk about growth and yield of forest stands, because it's important that we understand how forests grow, because that's what we're doing in silviculture. We are encouraging a forest to grow in one way or another. And finally, we'll conclude by talking about different ways that we can guide the forest along certain pathways towards what we want to get from it. Okay, so defining silviculture. When we start a topic, we generally define it, and here's our official definition, one official definition. This is from our Society of American Foresters Dictionary of Forestry, a compilation of forest terminology that we put together. And the definition for forestry here is the art and science of controlling the establishment, growth, composition, health, and quality of forests and woodlands to meet the diverse needs and values of landowners and society on a sustainable basis. So that's a long definition, and I often like to shorten it just a little bit. And this is the operational definition I carry around. It's the art and science of growing forests to benefit people, a little simpler version and one we can remember and take out into the field with us. Okay, so I think it's instructive to kind of, when we're starting to define silviculture, just take a look at where a formal approach to it. And this is our own forest resources management curriculum here that students follow in the pursuit of a Bachelor of Science degree in Forest Resources Management. And if you can see down here, silviculture takes place in the third year of their tenure here. And they start out in their first year, and the first forestry class is a careers class, an important one to take. And then they move over here to computing class, still kind of a general class. And it's not really until their second year that they get involved in the real forest type of work. In dendrology, that's the study of trees, where they learn all about, how, these different trees grow, their capabilities or their abilities to sustain different types of growing condition, and how to identify trees. And then they also take forest ecology, which combines, how trees interact with one another, how they interact with the animal community, with the soils, with the abiotic environment, the soils and the rocks and the atmosphere. And then after that, they move over to a very interesting topic. And I saw Paul DeRusca here. I believe he's a forest mensurationist. Forest mensuration, that's the measurement of trees and forests. And so they learn how to quantify a tree and be able to talk about what makes up an individual tree in terms of volumes and that kind of thing, and forests in terms of, how much and what is out on a whole wide forest stand. Oh, okay, so I'm just saying that you can't see this pointer icon. Voila. Thank you. Okay, so here's the silviculture, and hopefully you saw the path. Let's see here. Now, so it takes a lot of preparation to get to silviculture. After our formal definition, another definition that's kind of important is, who does silviculture? And we call these people silviculturists. And here's, I've actually looked in our dictionary of forestry. It was not there, so when the dictionary of forestry doesn't have it, it's off to look at the Wiktionary. So Wiktionary says a silviculturist is someone who practices silviculture, and a forester or a forester. And so let's see here. I'm getting distracted and someone can't hear something. So, but I'm going to continue on until Pete tells me he can't hear it. So anyway, so that's what a silviculturist is, a person who practices silviculture. Okay, so it wasn't very long ago, though, that I came to understand that silviculture was not only approachable on this formal basis, like I pointed out in our undergraduate curriculum. Like I said, it wasn't very long ago. I was taking a trip in southeastern France, and I was there to meet this woman on the left, Claire McGill. She was a grad student at the university there in France, and she's studying the silviculture of cork oak, as I photographed her by one of these trees that had just been harvested of the cork. Fascinating tree and experience. But while there, I had this opportunity to go to this eco museum and experience some really wonderful heritage. And if you are familiar with some of these eco museums, they're very much like our national heritage areas. You've probably all heard of the Pittsburgh Rivers of Steel and silos and smokestacks in Iowa. West Virginia has a coal heritage area down in our southern part of our state, and we're actually trying to get an Appalachian Forest heritage area between West Virginia and Maryland. And in any case, these are all heritage tourism areas that link local and regional sites with similar themes. Anyway, this one in southwestern France was based on the historic past of this Aquitaine region, that way back in the 1800s, it was a vast swampy and moorlands that had been sanitized, air quotes, sanitized, by draining the swamps and planting maritime pine, this Pinus pinaster here. And so this is a massive pine region now, and it developed into this big resin production area that, they tapped these resin trees and developed industrial solvent industry from it, much like our own southeast United States area. So in any case, tooling along there, I met another in Eco Museum volunteer, and Kathy, pictured here. We were talking about the resin distillation site that she was stationed to help guests, and she found out I was a forestry professional. She informed me that she was a silviculturist, and it kind of shocked me. It was the first time I'd ever met someone who looked at themselves as a silviculturist who hadn't been formally trained, so new eye-opener for me. And thinking about it, though, is that I'd argue that really anybody who grows forests is a silviculturist. If you own land with trees, you're a silviculturist. If you own property in the city with some trees on it that contributes to the urban forest, you're a silviculturist. If you sit on a tree board or beautification commission, even as a volunteer, you're likely a silviculturist. So I'm guessing most people on this conference call are silviculturists. So, long story, but important message. Most of us practice silviculture in one form or another. So continuing with this definition, defining silviculture, what it is and who does it, we come across these different adages or slogans. And one of them is this one of my favorites, is imitate nature and hasten its work, such as the maxim or slogan of silviculture. This was by Louis Perrot, who was one of the first directors of the forestry school pronounced Nancy, France. And this is the school that our own Gifford Pinchot attended to study forestry, way back when. Gifford Pinchot, of course, was our first leader of the USDA Forest Service. So pretty clear what he's trying to say, do what nature has done pretty much forever and try to make it go faster. So this imitate nature and hasten its work really brings on new questions for the silviculturist. How do we grow forests and woodlands in a way to hasten the development of the attributes we're seeking from the forest? How do we make a particular forest grow saw timber faster, for example? How do we make a forest provide a particular type of wildlife habitat for a longer period? How do we assure a healthy and continuously occurring forest in the long run? How do we make it more pollinator friendly? How do we make it more resistant or resilient from invasive species? So these are some of the questions we explore as silviculturists. So now we've defined silviculture a little bit, we are going to move into growth and yield, because generally that's what we want to hasten in our silviculture efforts. I just wanted to include this pretty tree picture because growth and yield, no offense to our forest measurements people out there, can get a little dry sometimes, but I'll try and move through it at a good clip. This photo is of Sugi, which is the Japanese cedar. It's a beautiful tree, and all over Japan, it's used for many different things, from some of their temple buildings to just regular construction. And basically, I would argue, think of Japan as a country that is based on concrete buildings and maybe associated with electronics, but really it's a nation and a culture that is really based on wood. Lots of wood over it. Beautiful. Okay, so on to growth and yield. Okay, so in any discussion about growth and yield, we have to recognize that trees have two main characteristic dimensions, we can call them. And one of these is the diameter, or the diameter of the tree trunk, and we generally take that at breast height. So we call it diameter breast height, or DBH. It's 4.5 feet up from the ground. And then we need to know this other dimension, something about the height or the length of the stem. So we call these characteristic dimensions because if you know something about that dimension, it tells you a lot more about other parts of the tree. If it's a big tree or tall tree or a thin or a short tree, it says a lot of other things about that tree. It tells you, how big its crown might be, or how much volume of wood or carbon might be in that trunk, or even the amount of leaf area might be on that tree. So other important variables are closely related to these two. By the way, I have put two little photographs down here. These are our mobile tree trunks that were painted by the artist and our urban forester with the West Virginia Division of Forestry, Liz Moss, when she was here as a grad student. And we take those around and teach people about how to measure this characteristic dimension with different tools indoors and during the winter. So, fun with forest measurements. Anyway, when you know these two characteristic dimensions, you can use them usually in equations to tell something else about the tree. In this case, we can use these dimensions to tell about how much wood is in the tree. For example, if we have a tree that is 34 inches in diameter breast height. Here's the diameter breast height through this column, 34 inches. And we have a stem of the tree that is 2.5 logs long, and we take this to the point where the stem is at least 10 inches in diameter. If we have 2.5, so 2.5 logs is, two 16-foot logs is 32, and a half log is 8 feet, so that's 40 feet of length. Then we can see we have about 1,000 board feet in that tree. And once we get that measurement, we can calculate. And I think I've blown this up. This is from our web page. Let me go next. We can calculate how much value is in that tree. And for example, if that tree was a black cherry, it's always fun to talk about black cherry because that's one of our most valuable trees here in West Virginia. The average price per 1,000 board feet, and fortunately we had exactly 1,000 board feet in our last example. That black cherry tree would be worth about $380 on average for the wood as it stands on the stump in the field. So important things you can get from those two characteristic dimensions. Okay, so continuing along this growth and yield topic, understanding how forests grow, again, is crucial to our ability to communicate about the forest and to understand how we might imitate nature and hasten its work. One of the ways we characterize that forest growth is by using what's called a yield curve. And if you are financial analysts, you might be more accustomed to a definition of yield like Investopedia puts it, the income returned on an investment. But from an agricultural standpoint, and timber is considered an agricultural crop, it is a measurement of the amount of a crop that was harvested per unit area, again from Investopedia. And so our yield curve is actually made up of two parts. The first part, the horizontal axis, represents the time. That can be, you can think of that as the time from the beginning of the stand, where maybe you have a bunch of small seedlings, or you can think of it as stand age. How old are the individual trees in the stand? And then it has this other, the vertical axis, that represents the quantity of a particular attribute we're interested in. And these could be anything, I have listed here, for example, saw log volume in board feet, pulpwood, generally measured maybe in tons, right? Carbon, a very important attribute in today's world with all these carbon projects going in. Total biomass in tons, or even value, dollars per acre, for the wood or some other attribute out there. Okay, and so also as part of this chart, we have this curvy line, a curvy black line, and that is actually represents the amount of the attribute at any point in time. So this curvy line begins kind of with a slow climb. We can think of this kind of as an establishment period for the forest or stand of trees we're working with. And then it begins to accelerate as it enters maybe an adolescent period. And then it finally hits this point, kind of, if we look at this growth curve as kind of a hill, it's on the shoulder of the hill where that rate, that annual rate of change hits a maximum. And beyond that is a plateau. And so you're still increasing the attribute, the amount of the attribute, but you're just not increasing it as quickly. And finally, we get out to this point here that you can actually see some decrease in yield as some of these larger trees might succumb to old age or disease or storms or such. Okay, so that is a yield curve. And the thing about the yield curve is that we really, when we look at it, we basically see one value at a time. And we need to remember that this is actually a complex mixture of a whole bunch of trees out on in this forest. But this yield defines really a product or a quantity of interest. And that quantity of interest changes at this unusual kind of rate, sometimes slower, sometimes faster, and then slowing down again, from a beginning to an end. And in forestry, our end point is generally when we harvest that off of the off of the property. And so we basically start over again at this 0 point, whether we plant trees or we have natural trees in place that will begin to grow again. Okay, but anyway, the time period from the beginning to the end is called a rotation. So a rotation is the life of a tree from when the trees in the forest start to when they're harvested. We call that a rotation. Okay, so it's important to know that these rotation periods can vary greatly, depending on the objectives of the landowner. This is an example. These photos on the right are an example of some farmers in the state of Andhra Pradesh, India, who have a very short rotation. The load of pulpwood, they're taking this pulpwood to a large paper plant in the state, and they can grow 25 tons per acre of eucalypt, shown above, in about 3 years. And that's worth about $520 an acre. So it's a really substantial amount of money for them. When we were there back in, I hate to say, like 2006, 2007, something like that, it was about $700 an acre. So really, they can make a good deal. And even more importantly, this photograph, this guy is standing out in different species. This Lucena, or they call it subabel. They can grow about the same amount, 25 tons per acre in 3 years. And the thing about that, you can kind of see how flat that is. Well, these are old rice fields, and they're old rice fields that are on the outskirts of the irrigation system. And so they're not always guaranteed water every year. And so, it's a big risk to try and plant rice. And so this is an alternative crop that's really benefited them. And so they do a short rotation silviculture there for producing pulp. Here in the central hardwood regions, we're more accustomed to rotation ages, to, growing these, mixed saw timber or even black cherry veneer, shown here with this good-looking forester, that are probably rotation ages. We say, probably between 60 and 80 years to get to some of these things. But again, this rotation length can be very different depending on the landowner and the objectives. Okay, so we have talked about yield curves. We've used stylized yield curves. This is a real yield curve. And this was taken from some data generated by a guy named Luther Schnurr way back in 1937. He was a silviculturist for the USD Forest Service, collected some really good data, and I'm using it here as an example. This yield curve has, again, the bottom stand age or time, right? 20 years, 40 years, 60 years, and so on. And board foot volume on the vertical axis. And the interesting thing about this is the unit we're using, board feet per acre, really doesn't show up in this stand until between year 20 and year 30. And this is because there are some minimum size requirements for these rules related to volume that say a tree smaller, a pine tree, at least Forest Service requirements, a pine tree smaller than 9 inches DBH or softwoods, those are the pines, firs, and spruces and such, have to be at least 9 inches DBH. And for the hardwoods, and that's all the other broadleaf trees out there, it has to have a DBH of at least 11 inches. So it takes a while for these trees to reach those sizes and start putting on board foot volume. Okay, so this discussion of yield curves and rotations leads to a point where we can talk about a distinction in different types of silviculture, and this distinction is really made on the age makeup of the trees in these forests and stands that we're working with. We divide these types of silviculture into even and uneven age. So this is another yield curve, right? We have this curve, again, board foot volume on the vertical axis and time on the lower axis. And we have the trees, the forest growing in the first period, the first rotation, right, for 70 years, and then we harvest it, right? And then it grows again, and then we harvest it after another 70 years. And then we let it grow, whether those trees are planted or they're naturally in place, let it grow, and then we harvest again. And so the idea here is that this rotation can occur again and again through time, and it's really allows us to communicate about the renewable and sustainable nature of silviculture. Okay, let me take a sip here. Alrighty, excuse me. Okay, so we had even age systems. Now this is an uneven age silviculture system, and this looks familiar, right? These are the little growth curves or yield curves that we have been talking about. But the thing, one of the differences here is that when these things grow, right, and we harvest them, we don't harvest all of the wood. In this example, we're only harvesting about, well, we're harvesting maybe 3,000 board feet per acre, and there's this line across that says we're retaining about 6,000 board feet out there. And the trees that we retain we call residuals or residual growing stock. And these trees continue to put on wood. And that's why when we look at one of these beginning points of these cycles, we don't have that lag period we saw in the even age to start putting board feet volume on, right, board foot volume. Those trees out there are already producing board foot volume, so we don't have the lag. Another difference here is between this kind of cycle and the even age cycle is the length of the time period, 10-year cutting cycle. And so every 10 years you might be going back into the stand and taking some more volume from it. And so the idea is to retain these trees that can continue to produce board foot volume, but as well you need to be thinking that there's something happening down here too. You're encouraging the stand to regenerate at the same time. We'll talk about that a little bit later. Anyway, so this is the uneven age silviculture, so the silvicultural system, and instead of rotation, we call these cutting cycles, and they're generally much shorter than rotations. Okay, so we talked about again yield curves. They're very helpful to talk about the pattern, the pathway of forest growth, but there's an enormous amount of complexity in our forest stands. And this complexity really begins with the composition of our forests. As I mentioned, our forestry students, one of their first classes is they have to take a dendrology class, which is studying all about all of the different attributes and abilities of these trees to live and produce in different conditions. One way to understand that complexity is to talk about forest structure and how it changes through time. And what is forest structure? You're looking at it. This is what we call a diameter distribution, and forest structure is basically the trees per acre by species. Here are the species down here, and they're represented by the colors in each of these bars, and size class. So these are size classes of the trees, the diameter class and 1-inch diameter classes. So for example, how do we read this? We look at this 2-inch diameter class, and there's about just over 400 trees per acre. Of those, check this out, this black is the red oak. So of this first bar, the 2-inch diameter class, we have about 170 red oaks in that 2-inch diameter class. And in the 3-inch diameter class, we have, maybe 60 red oaks. And in the 4-inch diameter class, we have about 150 trees and probably 50 red oaks and so forth. Way out here in the 9 and the 11-inch, not just a couple trees. One is a yellow poplar in the 9-inch class, and then this is a couple of old, probably remnant white oaks from a previous land use. Anyway, that's how we read that. And we could take a look at this and see how it changes through time to envision. So here's 1954. That was 1949. 5 years later, 1954. And look at how these diameters kind of spread out. The variation in these diameters get much broader. 1983, finally 1990. This is 40 years later. Here's our original distribution, diameter distribution, and here's what we're left with. We have a bunch of these small little, those are the light blue are the maples, and then we have this widely distributed group of trees, mostly dominated by the red oak group. So we can get another picture of this using a measure that we can call ecological dominance. And dominance, foresters run around, they use the term basal area, but for today, let's call it dominance. It's about the same thing. If you go up to a tree and wrap your arms around it at breast height, the area within your arms, that area in square feet is called the dominance or the basal area, whatever you prefer. So we have dominance over on the left-hand side. Again, we have these diameter classes, and we have all these species that are stacked upon each other. So for example, in the 2-inch diameter class, we have just under 10 square feet of base of dominance measurement in that class and so forth. But again, we can watch this as it develops, and that dominance measure weights the larger trees with more value. You know, it puts more dominance on the larger trees, and you'll see how that works. So watch that black class again, the red oaks, and these things develop, and as those oaks get bigger, they just become more and more dominant until 1969, 1974, 1983, 1990. We have the stand that's really more representative of what's going on out there. You know, that initial diameter distribution had this pretty much flat out in this area where all the oaks are dominating now. But again, you can see this group of smaller trees don't account for much basal area or dominance, but they're still residing, they're still hanging out there in the understory. Okay, but anyway, this is an oak-dominated stand, and pretty kind of interesting to see how those that complexity develops through time. Now, I wasn't going to put this in, but I have to. Anytime I use this sequence of photos in almost every talk I give, and it's just remarkable to allow people to see how forests change through time. So, just in the interest of describing complexity, describing how forest structure changes, I want to show these Arnault plots and how they develop. This is a USDA Forest Service. Just someone had a great vision way back in 1927 to start taking photographs of a timber harvest, and we are benefiting from it today. So, 1927. This is up in western Pennsylvania, and 1927 is a mixed broadleaf stand. And they did a saw timber harvest, taking all the big trees down to the sawmill, cut into lumber, right? And then they had a chemical wood industry where they could take some of the smaller trees all the way down to probably, 2 inches in diameter breast height, small little trees, almost very complete clear cuts they had. And they took this down to these chemical wood plants and heated the stems up and distilled out all sorts of industrial solvents. So 1937, 10 years later. So let's flip back one. So 1927, this is about 1 year old, because you can see all of the reproduction growing, some of the sprouts and seedlings already starting to grow back. So by 10 years, very dense thicket. This is what some of the wildlifers really like to see. It provides great cover for little grouse and small birds that are running away from hawks and things like that. But we expect to see many tens of thousands of stems per acre in a stand like this. And we can track this. There's this little blue and gold arrow that points to this black cherry stem. We can track that through time. So from these many tens of thousands of stems per acre, we go 20 years, so different already. I mean, we think that this early part of the life of the forest is one of the things we say it's a bloodbath, because there are so many stems that are dying out. They start from many tens of thousands. Here it's already down to 5,000 stems per acre. And 31 years old, 1,600 stems, and it's already developed. The black cherry's already got that burnt cornflake bark. You can look out there and see the maples. This guy up here is probably thinking, what am I going to do with all these little small stems? 31 years, okay, 45 years. It just continues to develop. And the big trees get bigger, and the small trees either kind of hang out there or they're gone. 1998. I know there's another slide here, but I don't have it. Anyway, 71 years, remarkable photo sequence of how forests change through time. So this is the message we give. Forest stands do grow. Trees are renewable resources. I think that so many people don't get to experience this kind of awareness that trees and forests grow, and usually we see forests speeding along the interstate at 70 miles an hour. So anyway, so there's other ways we can understand this complexity of forests, and one of the ways is to use these profiles or canopy profiles. If you've ever taken photographs in the forest, it's really hard to get kind of a broad view of what's going on in the forest. And so this is a canopy profile, and it's crucial for silviculturists to understand that the success of any tree is related to how successful that tree is in getting its crown into the sunlight. Because if it doesn't get it into the sunlight, it is not going to survive. So one of the ways we classify these trees is to put them into these social positions or crown classes. And I will just read some of the definitions that I'm pulling off our National 4-H Forestry Invitational website. If you haven't been there, it's a great website. And if you're a supporter of youth education in forestry, and you've got some big dollars, we're always looking for them. We've done this for 35 years. In West Virginia, we get from 16 to 22 states coming to compete. And anyway, so these definitions from our training glossary are the dominant trees are trees with crowns that extend above the average of the tree crowns and receives light from directly above and some from the sides. The co-dominant trees are trees with crowns that form the general level of the crown cover and receive full light from the top but very little from the sides. Now, I am reading this, and if you want to read, you're going to have to go to our website. And then intermediate trees are trees that are shorter than the two preceding classes, but with some branches extending into the general crown cover. It receives little light from above and none from the sides. And finally, these suppressed trees that are completely under the main canopy, way out of the light. All they get is the diffuse stuff. So crown classes are important attributes that allows us to, one of the things it allows us to do is to select good candidates for thinning. We want those strong, vigorous, dominant, and co-dominant trees, things that are going to respond to thinnings. Okay, so we've talked about slogans and adages, and we come across them at different times. One of them is manage the best sites first. And so, again, I go to our National 4-H Forestry Invitational website for a definition of what a site is. And site is an area's ecological factors considered with reference to its capacity to produce forests or other vegetation, the combination of biotic, climatic, and soil conditions of an area. So site is a very important thing for silviculturists for many different reasons, because obviously trees grow differently on different quality sites, and we can see this. Most of you have run along the interstate, seen something like this. I love seeing these things. These little Virginia pines, man, they are tough. These things will basically grow in anything they can get their roots into. But still, this would be considered a poor site for Virginia pine, because they can grow pretty well on other sites. Here's another example. This is an excellent site. This is an eastern white pine at our Rothkugel plantation in northern Pocahontas County. It's a historic plantation, although white pine wasn't one of the trees that was planted there. It was European larch and Norway spruce that still exists there, but a very excellent site. It has a great combination of biotic, climatic, and soil conditions there for good growth. Another thing one of the things that affects site is the position a tree is on a slope. And so it's intuitive pretty much, but as you start at a ridge top, when rain falls, where does it go? Downhill, right? And so with it goes the important moisture to the trees, but it also carries along with it nutrients. So as you go from the ridge to the mid slope to the lower slope, you have this gradient of both moisture and nutrients. So as you get down to the bottom, you generally have the better sites. Also affecting site is the site's aspect. That's basically the direction the slope is facing. And so let's start on these south-facing slopes. South-facing slopes, if you're a sunbather and like to go to the beach, you'd like the south-facing slopes, but it's a harsh place because it's always in the sunlight. It's very much in the sunlight, not always, but very much. It has most solar radiation hitting it, so has intense drying impacts, and it's a very dry area usually. And then when you have this combination of being on the top of the ridge where there's little moisture and few nutrients, and are being beamed all day by sun, it makes particularly harsh sites. On the north-facing slopes, they're a little bit more shaded and a little bit cooler and protected from harsh solar radiation. And so these tend to be the richer sites on north-facing slopes. So both slope position and aspect effect site. Okay, well, we can go back to our curves from Luther Schnurr, and there's actually an index we can use to represent how good a site is. It's called site index, and here's a definition taken from our Canadian colleagues. Site index is an expression of forest site quality based on the height at a specific age or a specified age of the dominant and co-dominant trees in the stand. So we basically here in the Central Hardwood Forest take a base age of 50. Now these base ages can vary depending on where you are in the world. I'm pretty sure down in South America where they're growing like radiata pine and eucalypts, and over in where I gave an example in India where these short rotation woody crops, some of these site indices may be based on a few dozen months. So, but ours are based on 50 years. And so when a tree is 50 years old at a stand, and you look at the dominance and co-dominance, and they're 40 feet tall, that represents a 40-foot site index of 40. If they are at age 50, 60 feet tall, that represents a site index of 60, and so forth. An excellent site is a site index of 80. Those are the co-dominant and dominant trees at age 50 that are 80 feet tall. So if you have 50-year-old trees that are 80 feet tall, you have a site index 80 type of growing condition. Okay, so it's interesting also to take a look at the effect of site on some of the attributes we were talking about. This is the number of trees per acre, and look what's on top. The poor site. This is the poor site, and so at age 10 you have more trees on the poor site, fewer on the excellent site. And basically the reason for that is that on the excellent site, these trees are growing like gangbusters, and so they're taking up the available space more quickly than on the poor sites, and so they're killing each other out more quickly, and so they have fewer of them. But site makes a big impact on that attribute. Board foot volume, something that's very much of interest to many landowners because board foot volume equates into financial value as well. Look at the difference in these sites. Well, this is year 100, but in any case, at a year 100, we can use that as an example. We have about 10,000 board feet per acre, which is a good amount. But on a poor site, but on an excellent site, we have like almost 35,000 board feet, more than 3 times as much. So site can just have an enormously actually good, if you have good sites, impact on growth of trees. Okay, so there are a whole number of factors that affect tree growth. Light, moisture, nutrients. We've talked a little bit about some of these. Each one of these are pretty much a topic of their own. Soil depth and quality, temperature, health, pests and disease, all those things impact tree growth. Light is one that we really have something that we can work with. We can control light in stands in different ways, and I'll go into that a little bit. I just want to show Valerie Grant here. She's our West Virginia Woodland Welcome Wagon Coordinator. She's taking a picture. She's from California originally, and this is when she was 23 years old, and she's holding this ponderosa pine that is 23 years old here, and this one also is 23 years old. So big deal of difference, and these the differences in size here for these two stems of the same age are one was in the shade and on a poor site, and the other was on a very good growing site. Obviously, not much competition there, just tremendous growth. So anyway, so light is one of those factors that we can manipulate in forest stands, and so we can control this factor. And there's 2 motivations for doing this, for controlling light, and one of them is to modify the growth rates of the stand. And I say modify because we could increase the growth rate. We might want to decrease the growth rate of some parts of the stand. And then we can also modify the growth rate by modifying what is growing, so the composition of the forest. And then the other motivation is at some point we want to assure that we're regenerating our forests. And so controlling the light will allow us to do that. Okay, so in controlling forests, remember I was talking about dendrology again, and how important that is. We there understand, some of these attributes and abilities of the individual tree species to tolerate different things. Can they tolerate shade? Can they tolerate certain types of stress? Can they tolerate flooding? And for shade, which is kind of the opposite of light, right? We're going to say we're controlling light, but we're also controlling shade, or we're controlling light by creating shade. Different tree species have different abilities to tolerate that shade. And it's well known that black cherry, yellow poplar, the birches, aspen, some of the oaks, some of the pines are very intolerant to shade. They just can't do very well at all under shade. And then there are some others that are very tolerant to the shade. It's really not a problem for them to hang out for a few decades or more until they get openings that, in the canopy that beam down some light on them and they can continue their growth upward. And these include sugar maple, American beech forest, red maple, kind of intermediate, flowering dogwood, pawpaw. Those are two things that kind of reside in the understory. They're small trees that are very accustomed to that, as well as some of the conifers we see, eastern hemlock and red spruce. Those are very tolerant of shade. Okay, so this section is guiding the forest along the pathway. Now that we've talked about these different ways that forests grow, their general pathways, something about the complexity and how that complexity may influence what we see at the beginning of the life of the stand and at the end. We've talked a little bit about that. And so in talking about guiding the pathway, we're really talking about how we can hasten a forest's growth, as Louis Perrod has said. And one of the things that is important when we talk about how we guide the forest along a pathway is our objectives. And I'm really not going into objectives because I know people have talked about them. There's all sorts. But I like to use this slide that came off our little West Virginia Woodland Stewards page that Arlen Perkey posted. This is a property that's out in western Monongalia County in northern West Virginia. Arlen, of course, is a former forest and still is a silviculturist out. He has a couple properties and still teaches and instructs us all how to grow trees better. And he says, this black gum tree at Catherine's Knob, that's his property in western Mon County, earns its space by being reliably beautiful every fall. And so not only is Arlen a silviculturist, he's a great poet, and it really says something about people's values for their property, because black gum, from a timber standpoint, I'm not going to say it's a weed species, but we could. We could say there's very little value in the wood in that tree, but it has all sorts of other great properties. Beauty is one of the most one of the greatest. Okay. So some of the aims of this movement or this guiding the forest along the pathway are, again, to modify the growth, and then the second is to regenerate the woodlands. We can modify growth. I said, controlling light, but really, honestly, in certain settings, especially with planted forests, we can have certain types of soil amendments, irrigation, fertigation, where you irrigate and fertilize at the same time in some settings, and so forth. But generally, that's not done in natural systems that we work with, at least here in West Virginia. I know that there's some short rotation woody crop research going on, and they're trying to promote that as a biofuel. So that may have more of a application in that type of silviculture. But mostly what we do are thinnings. We modify the growth rates of the forest, and then we can modify the composition of the forest. So I'm going to talk a little bit first about, very briefly here about, okay, about thinning. Clearly thinning has some great benefits. And this is a slide I use all the time. Jonathan Case from Maryland Extension lets me use this. And this is a photograph of two tree cookies. You've probably seen these before, but 25 years ago, both these trees were the same diameter. Here's the center of the trees, right? And at 25 years ago, they were both about this diameter. Well, this section, this wedge of the tree cookie this tree was thinned, of course. And that growth just accelerated. And in 25 years, it grew this much. This one, however, was unthinned. It just kind of stayed there and continued to do what it was doing. So great opportunity for adding value to your trees through thinning. The company I worked for, West Fayetteville, back then, was doing pre-commercial thinning, thinning young stands, 15 years old, 15 to 20-year-old stands, and people would comment, they'd go into a 30-year-old stand and say, this thing looks like it's a 45-year-old stand. And so it can really make a big difference in terms of adding volume and adding high quality saw timber to your forest. Okay, so clearly there's a benefit. One of the biggest advances, I think, in recent history has been this crop tree management. The thought about crop tree management. It was really Arlen Perky, who I showed or mentioned earlier, who kind of brought this and popularized it. But all I'm going to say about it is that it allows us to focus on the individual tree. We select trees that are good quality trees for thinning. Ones that we know are going to respond, like those cookie wedges we saw of Jonathan's, respond to a thinning. And so that's the thought of crop tree management. We look at these things, we can talk about these free to grow classes. So we have a subject tree there in the middle. We can talk about, one-sided, two-sided crown release, three-sided crown release, four-sided, and so forth. And we can look at data that says, here's an example, again, from one of his publications, where you have the number of sides released down here on the bottom. And over here on the vertical axis, you have growth rate in inches per decade. So here are these ones that have been thinned on four sides, 3.9 inches in diameter per 10 years, versus unthinned 1.3. So you get, just about 3 times the growth when you thin a tree. Now that, sounds like a good investment. When you look at these four-sided crown releases, this is actually 18 years after a crop tree release was put in for a demonstration area up on our Cooper's Rock State Forest, just outside of Morgantown. And Arlen Perky put that in as well. And but it reminds me of something I heard over in Virginia at a training session. A forester named Tom Deeroff was sharing with us in this training group that one of his mentors had told him once that, when you do a thinning and you look up and it looks like you got just the right amount of trees out, you probably haven't taken enough. And so sometimes these thinnings can look pretty severe and after you've done them, but they really need a lot of space to grow. So that's kind of another art in itself, is thinning. But we can look at all the different types of trees, and they all pretty much respond to thinnings. Again, I start moving along here. How we select crop trees. I know there's a number of webinars that have been carried out about those. Different species have different values, as we saw in our stumpage values. They have different financial values. They have different values to wildlife. They have different abilities to regenerate following some kind of treatment. So you really have to be careful in that. And that's where we're going next. Finally, we're going to talk about this other component, is that different ways we can regenerate our forest. This is a photograph of a very intensive timber production area. You might look out there and go, hey, it's a clear cut. Well, there's actually a number of clear cuts. Here in the foreground, that's a new clear cut. This is probably 1 or 2 years old. Here's probably a 4 or 5 year old. This may even be a clear cut from, I'd say, maybe 10 to 20 years old. Since that kind of, it's kind of hard to tell from here, but there's actually quite a few clear cuts, and it's a very dynamic place. So notice it has there's a lot of impact on these areas, but it's a very rich and valuable site for growing timber. Okay, so the different types of regeneration methods basically have to do with the amount of sunlight we're putting down on the ground. Of course, one of the most famous types of regeneration cuttings or methods is the clear cut or clear felling method. These are even age regeneration methods. Again, remember, all the trees in the stand are going to be about the same age as they grow and eventually will be harvested at rotation age. The maximum amount of light is given to every one of the stems out in here because all of the trees are removed. And this type of harvest promotes development of shade intolerance. So the cherries, the yellow poplars, some of the oaks, all those things that can't really tolerate much shade will really do well in these types of settings. Here's a clear cut, visually pleasing to some. Have stories about those, but we'll move on. Again, these clear cuts we've seen in the photo sequence earlier of the little R0 plots, with the tens of thousands of stems produced, a great way to produce different types of habitat. Anyway, on to the seed tree method. We're going to leave a few more trees out. We're not going to cut everything. We're going to just leave a few. We generally don't see these seed tree cuts here in the central Appalachians or central hardwood forest. You see a lot of these down south where trees have seeds that are windborne. So if you leave these standards or these residuals out on the land, they'll continue to shed seed that'll become established as time goes on. Another is the shelterwood method. This we leave a few more trees yet as reserves or residuals for one purpose or another. Sometimes they're to provide additional seed fall. Sometimes they're to provide some type of environmental protection like shading. And then eventually it's overwood. These residual trees are going to be harvested. That's the plan. This is actually a photograph of some property down in Nicholas County, and the company found that by retaining some of these overwood trees, retaining some residuals, they didn't get as much pinch area, a very shade intolerant species. They didn't get as much back when they harvested timber. So shelterwood method, but it's another even age method. This looks like a clear cut, but it's actually the final overstory removal of a shelterwood cut. 15 years worth of work went into this to get it to this point. And now we actually have quite a good mixture of oaks in this stand. Okay, uneven age methods are much more complex, and because it has to do with, remember, the cutting cycles every 10 or 15 or 20 years, whatever your management says to do, but they're more complex. They promote shade tolerant species like the maples, maybe the hemlocks, the beech. There's a lot of shade left out there because you have so many different aged trees and different sized trees. But this does promote these shade tolerant trees. It also maintains some degree of financial flexibility because you always have some trees out there to cut if you need, if you find yourself in need of generating some revenue from those trees. And it's arguably the most aesthetically pleasing. You always have a nice canopy, at least in some places on your property, to provide some shade and some bird habitat and some other attributes. A visual quality. This is actually an even age cut, but with some residual trees for a visual buffer. So threw that in there just kind of an even age system, but not completely. So I can't get out of this webinar without saying something about diameter limit cutting. Here's another canopy profile. This was done on some trees up on the Cane Experimental Forest. You can see the black cherry, which everyone likes. An old American beech that was probably one of those residual from the days of the chemical wood harvest. And all the big trees are marked, a diameter limit cut. Well, basically, as most of you can guess, you cut those things without thinking about the understory, and that's what you're left. You're left with a bunch of trees that basically are the losers in the fight for light. We saw that photo sequence, and these are the ones that really didn't make it up into the main canopy. You think those things are going to respond to additional sunlight? Probably not. And so you might as well just clear cut the thing and have them all start over again. So in any case, so we kind of define silviculture as something that most of us do. The art and science of growing forests to benefit people, and talked about different growth pathways and the complexity of those pathways, and finally wrapped it up with some really, really very general types of ways we can guide forests along these productive pathways and focus on one species or other species, depending on whether we retain more or fewer trees. So that's it. Here's my contact information if anyone ever wants to get in touch. We have a little site here, our West Virginia Woodland Stewards, where we post workshops and such and seminars. There's not a whole lot of them right now because we've all been busy this winter, but we are starting to get our summer programs together. We have some firewood processing seminars coming up, so maybe we'll see you out there. So that's it, Pete. Do we get sound back or anything, or do we just?
Yes, we get sound back. Sorry, I was just trying to copy and paste the.
Oh, great. There's a link.
There's a link, but then the exit survey, just to make sure people have access to that, and we'll provide that also when you leave. So, Dave, this was a fabulous presentation. I really enjoyed this, and you covered the early parts where you covered the foundations of being able to understand the later parts was really well orchestrated. So I want to thank you. You put a lot of effort into preparing for this. So, so this is a chance when people want to ask questions. There was a few questions that came during the presentation. I answered some of those. I think we've got those covered, but we can scroll backwards. But if people have questions, this is a good time to ask them. As host, I have the prerogative of leading the questions. And I wonder if you could, and you may want to scroll back, use your thumbnails to scroll back to that yield curve, which I thought was great. And it just occurred to me that this would be maybe a chance to, you showed a shape to that curve, so it started slowly and then it.
Oh, right, that one. Okay, absolutely. Kind of at the beginning there. Huh?
Yeah, it's towards the beginning.
Yeah,
that one, perfect.
Okay.
So this is a curve that would be based on one of the attributes, but and I'm not looking for specific descriptions, but just clarification. So let's say let's say this curve depicts sawlog volume. If you were, what factors would make the shape of this curve change? So it would be things like site quality, the attributes. So if you're looking, maybe somebody's interested in timber, but you also talked about, Arlen Perky. That was a great quote about the aesthetics of trees. But let's say somebody's interested in turkeys, and so they're interested in acorn production. Would you? So how does the shape of the curve change depending upon different factors that a landowner might be dealing with?
Well, I showed you what they might be able to change on it, or what because we showed those the site effects on these growth curves. The better the site, the more rapid the growth in our attributes generally, or the faster the reduction of trees on the site. But if they are what they want, they want to get to, if they're interested in turkeys and producing acorns, and they don't have oak trees, and they're just kind of starting out, or they have maybe an old field growing up. Or are you talking about like planting a bunch of oak trees and kind of starting from a pasture setting?
Yeah, well, so any of those.
The target would be getting a bunch of acorns, right, for the turkeys. Is that
right? Well, so that's part of some. So if we just look at the plateau section, for example, so the width of that plateau section might vary depending upon what it is you're focused on. Is that a safe assumption?
Yeah, and in fact, the maximum point I was telling you about, it's also very flat. When you start looking at these maximum growth periods, there's a lot of leeway on this side or that side of some more estimates of growth rates. And so that's where you want to be, that plateau. You've got a bunch of big oaks producing acorns, and so you can encourage those. And actually, when we talk about thinnings, and some of the oaks can really continue to respond to thinnings into 75 years or more. You can find Forest Service publications, by well, I don't know when the last one was, but back in the 70s, I think they were still doing thinning research, maybe the 80s, on individual trees, and there's some that show black cherry, northern red oak. Those species respond even at those kind of older ages. Yeah, I threw a question down here. What is suggested residual basal area for a seed tree harvest? Boy, like I said, we see a lot of seed tree. Should I just answer like verbally?
Sure. Oh, yeah.
Okay. We see a lot of seed tree harvest down south in our southern pineries, because pine, of course, have, when the cones open, those seeds have this little wing on them, and they go floating off, flying off, kind of like the maple samara, right? The maple seed. And so we see a lot of them down there. And I would say, boy, 5 square feet of basal area at the most. Some of those are very, very sparse. We have something we call deferment cuts, and they're kind of these clear cuts with these reserve trees out there that are, high quality. They look good, and they're kept out there maybe for visual quality or for wildlife purposes, but those are about 20 square feet, and those look pretty sparse too. So, but definitely under 20 square feet. Honestly, I haven't really worked with the seed tree cut because, like I said, you usually see those down south. Pete, do you have any experience with those?
I'd say that your number is probably in the ballpark that I would have said 5 to 10 square feet, and I tend to think more in terms of number of stems per acre.
Right.
And if you have a 14-inch tree is about 1 square foot of basal area, and so let's say you're leaving behind 18 or 20-inch diameter trees. If you had 5 to 10 square feet of basal area, you're leaving behind 5 or 8 trees per acre on a seed tree cut, which is, I usually think about 8 to 12 trees on a seed tree. We'll do some with sugar maple, or if you had some as you say, wind dispersed trees, and then on the shelter woods, we're more in the 30 to 40, I think, square feet of basal area. Is that what you'd think, Dave?
I think so. I think when I was up at Penn State, I think Joe Harding there, he used to be the manager. I think he still manages somewhat on that experimental forest at Stone Valley. I think he was leaving like 50 to 40, 50, but just a little bit.
Okay.
Not, it's not. Right. But yeah.
So do you want to? So Emily's talking about 2-age stands, which you didn't mention. Do you want to talk a little bit about just maybe in general terms, and then if you have some parameters to bound that?
Yeah, 2-age stands are, it just seems like, I don't know the whole history of those, but it seems like 2-age stand was one that slipped through the cracks of forestry definitions early on in forestry, because we have the uneven age management. 2-age stands arguably are, uneven age, but the uneven age definition had to do with 3 or more age classes. And so 2 slipped in there, and it makes a lot of sense. I've seen it done. And in fact, these deferment cuts could be thought of as 2-age stands because you actually get this regeneration coming up under these larger residual trees that are only about 20 square feet per acre. So yeah, I would call that a 2-age stand. But again, those I'm not real clear about kind of the end point of those. I think some people would, harvest the larger trees. There's all sorts of logistical issues with that. You got all these big trees with a whole bunch of little ones growing up around it. And then how do you get those big trees out without, substantial damage to small ones? I would call it a 2-age stand. I'm not quite sure what the rules on that definition are. How long you have to keep the reproduction coming on before you can take the trees off and still call it a 2-age stand. Not sure.
Okay, good. And Tom is asking about the role of sprouts in the even age, sprouts versus seedling establishment for regeneration. And maybe that depends upon the kind of the specifics of the species, or.
Yeah, boy. Yeah, absolutely. I mean, you think about, these areas in Maine, and we said we had a bunch of people in Maine and Wisconsin, the lake states that have, a higher proportion of some of the aspens than we have here. We have some trembling aspen or quaking aspen up high elevation, dolly sods, high mountains. And then we have the big tooth aspen kind of down lower and more dispersed around our state, more common. But, when you harvest those things, the recommendation is, boy, you hit it hard. And those things, they sprout up from suckers, these adventitious stems that come up from the roots. And not every tree does that. And so that's one that you definitely rely on. We can call them sprouts or suckers. But I've seen studies that have gone out after timber harvesting and looked at the origin of these things. And I actually have some slides I fortunately didn't put in here because it would have been way too long. But we talk about each of those different types. You have suckers, you can put cuttings in that are kind of this funny adventitious thing. You stick a stem in, it grows roots. But sprouts, you have a couple different types of sprouts. You have stump sprouts that we usually think of, right? And then you have seedling sprouts. And really the only difference there is this funny arbitrary cut point where we say that a stump is anything greater than 2 inches. And so you have these little seedlings that are less than 2 inches at stem collar, and those will sprout. And then you have the big stumps that those will sprout too. So there's the same origin. Those the shoots come from dormant buds that kind of are underneath the bark of most of these trees, and in fact they're the same origin as the epicormic sprouts we see up along the stem when there's some kind of impact to the crown. Those things pop out of the stem. Same origin. They're dormant buds, and so yeah, there's a huge proportion of the reproduction in most of our hardwood stands that come from sprouts. A lot of them are from seedling sprouts. In fact, one of the interesting things about oak is that there's been studies that have gone out there and dug up these roots and measured the root age of the seedling and found it to be like up to 30 years old. And you have this kind of little sprout that keeps popping up, and then because it's kind of in the sunlight or gets browsed off or something, it dies back, but then it'll sprout up again. It just produces enough carbohydrate apparently to have kept that thing alive for 30 years. And of course, they don't all live for 30 years, but there's this kind of distribution of ages of oaks in the understory. But the stems aren't that old, but the roots are. So yeah, I mean, it's super important. These little seedlings we see in the forest, these advanced seedlings or advanced reproduction, those stems might not persist, but they might break off, and the new sprouts have a great advantage over new seedlings in terms of getting established and getting their crowns up to the sunlight.
Okay, so Jim is asking about board foot volume per acre, and you showed the slides, I think, where you're comparing low, medium, and high quality sites and kind of a range of 10,000 to 35,000, and he was thinking it's more like 8,000 in New York. And so I know, Dave, you're going to say, well, Pete, what do you think? And I don't know. So I'll throw that out to a forester that's working in New York or Pennsylvania or New England. I know. Okay, good. Go ahead.
Yeah.
You go.
Well, the volume tables I was using, of course, are from 1937. And those volume tables were developed using what are called normal they're normal yield tables, essentially, is what the name is. And they're generated by going out into these well-stocked stands, kind of at their full potential for the site that they're looking at. And some of the attributes that you might look for a fully stocked stand is, complete canopy, not a bunch of big gaps, and there hasn't been a disturbance for a long time, those kinds of attributes. And so these tables were developed from those kinds of stands. So it's really the maximum potential for that forest type. And yeah, when I was at I've seen many timber suites, and of course some of these sales had been in areas that had been cut 20, 25 years prior in one particular way, but still they were yielding, the average was between 2 and 10,000 board feet per acre. And so we'd expect to see something much lower, unless you have a stand that hasn't been disturbed for a while. I don't know if that answered it, but yeah, that's why I was using the big numbers, because those are actually called normal yield tables, showing the full potential of that type of a forest.
Right, and some of the volumes would depend a little bit on species. I know I have in our woodlot, I have a stand that's dominated by white pine, and I have it's not a very big stand, but I've measured something on the order, I think 20, as I recall, 20,000 board feet per acre. But white pine can accumulate lots, and conifers can accumulate a lot of volume per acre. So I think, Jim, your observation of 8,000 is, for what we commonly see, is pretty typical. So I don't know about pawpaw, and I don't know if so.
South central New York, I'm not sure. It grows down here below 2,000 feet. But I see someone's a mountaineer out there. Good to see.
Yeah.
And what else? I thought I'd say.
Joe was asking about sources of value species for tree seedlings. I'm reading this to be a tree planting question for New York. So the New York State DEC has their tree nursery in Saratoga. If you look up New York State NYS DEC tree nursery, you could get that information. They have a lot of valuable species if you're going to replant. But the most cost-effective way to do it would be through natural regeneration. In all cases, natural or artificial. You're going to have to control for deer. Okay, Tom Ward wants to know if you could contrast the difference between silviculture. Well, Dave, you can read that, right?
Silviculture practice on professionally unmanaged forests versus high grading.
Professionally managed
forest,
okay.
Which is worse than unmanaged. I'm not sure if I don't hear a little politicalness in there. Maybe we should ask Tom about that. It sounds like he knows a lot. Well, silviculture, yeah, it's all about intention. And, we talk about the guiding the forest along the pathway. That's all intention. You have an objective. And so we carry out certain practices to make that objective come true. High grading basically is cutting the forest. And that's it. When we talk about high grading, it's cutting the biggest and best. And yeah, I'd agree with that. Mismanaged, totally. And then unmanaged forests, not sure exactly what that means because most, even forests that we allow to grow without any kind of timber management, on one hand, you could say, some people, you can listen to foresters, and some of them hold the position that if you don't harvest trees, it's really not being managed. Well, we can manage national parks, right? But our objective is kind of the preservation of the ecological processes there. Same with forests. You don't have to cut your trees. They're going to live a long time. There's risk in not cutting trees. There's risk in leaving a bunch of valuable trees standing out there. Because the larger, more valuable they are, the more you risk, because they get blown over, they can get struck by lightning. There's all sorts of challenges in managing our forests in different ways. But unmanaged, I'm not 100% sure I get that. Oh yeah. Okay. So Tom says, especially in New York and New England, there's so many hardwood stands where the best species in form class have been selected and removed 2 or 3 times. Absolutely. And it's funny, when I was in Wisconsin, I was working on a red oak stocking chart. It's this chart that allows us to kind of gauge where our stand is with respect to kind of one of these potential for the type of stand. And I went into all these wonderful, red oak stands, but they had been in there, 30, 40 years prior, harvesting even bigger trees, and so yeah, I mean, we humans, use the forest and we use it for what we want at the time, and in some ways, we're kind of left with what we're given, and there's not a lot of intention to the forestry that goes on, and that's why, promoting silviculture is so important, is because it has to do with, our intention to move a forest in one direction or another. How are we going to guide this forest so that it continues to produce what we want it to produce?
Okay. Well, I think on that note, we're at about 1:20, and we've been purging Dave's brain here for almost an hour and a half. And again, Dave, this was a fabulous presentation. Thanks very much for the effort you put into it. And we had a good attendance. We had about 60 people, and I think there's about 90 total that have registered. So I'd guess we get another 20 or 25 this evening. So thank you, Dave, and thank you all to the participants. And we will, for the participants, just keep your May calendar tuned in to the 20th. We're going to have Dave Jackson from Penn State talking about herbicides. And for those of you who want to see another go-around on silviculture, Dave McGill will be back this evening at 7 p.m.
Oh, boy.
All right. Thank you all. Thank you all very much.